Welcome back to che205 Numerical Methods for Chemical Engineering. In this video, I'll be showing how to find the root of a function using direct substitution method. For this method, we're going to look at the same example for which we solved using plotting technique in spreadsheet. That was the equation of state, where pressure, volume, and temperature are related through the van der Waals equation of state, which is given by this equation. The goal was to find the volume for a given pressure and temperature. So today we're going to look at how we can find the root using direct substitution. Last time we looked at how we can estimate that root. Alright, so these are the constants that are given. R, P is the pressure, T is the temperature in Kelvin, A and B are the other two constants. So what we can do is the following. So in direct substitution, the goal is to convert a function like f of x, for which we're going to find the root of, to something like x equals g of x. Alright, so if you want to find the root of this function f of x, we have to convert it to something else like x equal another function of x. So the left hand side has to be x, the right hand side has to be a function of that x. Let's see what this exactly means in this specific example. If I want to find the root of this using direct substitution, then we have to convert this into the variable, which is v in here, not x, because now everything is in terms of v. V is our variable. So I have to convert this to v equals something else. So to do that, I'm going to add RT to both sides, and then divide through by p plus av squared, and then add v to both sides again. So what you end up getting is v equals b plus RT over this. So again, to get to here from there is we add RT to both sides, then we divide through by this parenthesis, or these parentheses, and then we add b to both sides, then we get this equation, which is v equals b plus RT times RT over p plus a over v squared. Alright, so this is exactly in the form of x equals g of x. In this case, we have v equals g of v. So this is g of v, which I have here. That means a function of v. So what should we do next? Then we're going to start with the guess value for v. So I create two columns, v and g of v. And in the v column, we're going to start with a guess. So what would be the good guess? The good guess would be exactly what we guessed from the plotting in the spreadsheet using the last lecture, right? So if you remember from last lecture, the guess was 4.2, which was close to the root of this function. So I'm going to start maybe with 4. So let's start from 4. I'm going to put 4 here. Then I have to evaluate g of v. So to evaluate g of v, we start with equality sign, so equals, and then we have to type this equation exactly, b plus rt. So what is b? So here's b, I'm going to click on that. Since b is not going to change the constant, we have to put a dollar sign behind the numerical index. So put $7. Alright, so this is b plus, look at here, r times t. So what is r? Is this cell. You have to freeze the numerical index. So here's $sign behind 3. 1 times temperature, which is this cell, and that is constant too. So we have to freeze the numerical index. And then divide by, so here's divide, oops. So divide by, open the parentheses. P is another constant, we're not changing pressure, right? So pressure is fixed. So I'm going to click on this cell, we have to freeze the numerical index, plus A, which is this constant, divide by V squared, so here's V. We're not going to freeze the numerical index because we're going to change v as we go down in this column, and the numerical index should also go up, so we do not freeze the numerical index. Alright, to the second power, close the parenthesis, and then that's it. So I type v plus rt over this, and that's exactly what I have here. So you see how I actually replace the variables in a spreadsheet. Everything is using the cell address. You see that there's no A, there's no B, there's no P, nothing except the cell addresses. Alright, so you hit enter. Alright, so this is G of V. What do you do next? Next is, so we're going to have our next value for V would be exactly the previous value for G of V. So start here with equals, and then I'm going to have this cell exactly equal to that cell. So I'm going to click on this cell, and then enter. So this cell now is going to be identical to this cell. What will be the next step? So now we're going to have G of V evaluated for this V. And to do that, we're going to click on this cell and just drag this guy one level down. There you go. So we have to repeat this step until V and G of V would be exactly the same. That means no matter how many iterations you do next, your V is not going to change anymore. So if V is not going to change anymore, that means that V is the root. So let me expand this a little bit so you see more digits here. We can increase the number of digits by hitting this key one more time. Let's say I have 5 digits here. I'm going to keep 5 digits here as well. So let's go to 5 digits. There you go. And you see that these are different. So this is 21854. This is 22946. That means I have to still, I have to keep going until these two become equal. So what would the next step? Again, this cell is exactly equal to that cell, but I already implemented that. So what I do next is I can highlight these two together, and now drag one level down. And you see that they're getting closer. One level down further. They're getting more closer, or further closer. And then one level down, and they're almost identical. There you go. So the root is going to be, in fact, if you even scroll down further or drag down further, this is not going to change anymore. You see that 22998 is going to be fixed after that. So the very first time we see that these two are equal, that is going to be the root. So the root is going to be 4.22998, which is close to the guess we had before from last lecture, if you recall, which was 4.2. So this is how we can use direct substitution to find the root of a function. To recap, we first convert the equation we have into x equal g of x. For this equation of state, we convert it to v equal g of v. Well, it doesn't matter actually, because v is the same as x, and g of x would be the same as g of v. Alright, we're going to create two columns, one for v, one for g of v, or one for x, one for g of x. We start with a guess. How we can find the guess? Well, you have to look at the plot, the function. You have to plot the function, and then look at where the curve hits the x-axis. That would give you a rough estimate of the estimate, or the rough guess for the estimate. Alright, so we're going to start with 4. Then you have to type in the equation for g of v. You evaluate v, which is going to be g of v. The next step would be you equate the next v to be the g of v of the previous step. So this cell is going to be exactly equal to that cell. And then for the rest of it, we're going to highlight this cell and drag down one level. Now we get these two populated. Then we're going to highlight these two and drag down a few more steps. We have to go all the way down until we see that v and g of v never change, and they're identical. That is where we have to introduce, or we have to claim the root as the value of the v is not going to change, which is in this case 4.22998. Okay, so I hope you'll learn how to find the root of a function using direct substitution. In the next video, we're going to talk about a third method, which is bisection, and we're going to see how we can use bisection now to find the root of the same function. So stay tuned, and thanks for watching.